This is the first video in our chapter on exponents. So if you'll take a look at the top of your notes, let's just look at a quick definition. When you have something expressed with an exponent, we call this the base, and we call this, as you know, the exponent. But what it means is what's important. It means 4 copies of 5. So 1, 2, 3, 4, and they are multiplied together. And you don't need to multiply that out and find out what it is. It's just a way of expressing the meaning of 5 to the 4th power. So let's look at a few of these, and it says to evaluate them. So we are going to figure out what they mean. 2 to the 3rd power means 3 copies of 2, or 8. 3 to the 1st power means 1 copy of 3, or just 3. And from here, I think we can probably generalize that anything to the 1st power is just itself. And in fact, you actually wouldn't even show that 1. That's not typically done. I want you to pay a special attention to C and D examples because they are different even though they look similar. This one, the exponent applies to the parentheses. So what it means is 2 copies of -4, which is negative times a negative is a positive 16. However, this one does not mean that. This one means minus 4 squared. So it means minus 2 copies of 4, which is -16. My guess is that you would probably get this one right and be more likely to miss this one. This one does not mean -4 times -4. The exponent only applies to its base, so that negative is just a minus sign out in the front. In E, the squaring or the 2nd power belongs to everything in parentheses, so it means 2 copies of 1/2. or 1/2 times 1/2, which is 1/4. Here we just want to expand what this means. It's sort of similar to this one, where the exponent only applies to the base that it is close to, so it means 4 times x times x. That's all I wanted you to do on that one, was expand that. All right, in example 2, it's asking us to evaluate the expression if we're given a certain value of x. So in example A, we have 2x cubed if x is 5. The safest way to write this is to write your 2, take out the x, put parentheses in, take the number that goes in, put it there, and then write the cube. So you can make sure that you are cubing just the appropriate base and not the whole thing. Now, order of operations tells us that you have to do the exponent first. You can't say 2 times 5. You'll get something completely different. So 5 cubed would be 5 times 5 times 5. So what we have is 2 times, that's equal to 125, or 250. So remember your order of operations. It's not that these are difficult. It's that you have to be very careful with order of operations. All right, you should pause the video and try this one on your own and then come back and check. I'm assuming that you did that. So if you followed my directions for this one, what you should have done is written 9 over, and then you should have had parentheses, and the -3 goes in, and it's squared, which means 9 over -3 times -3 is positive 9. So you get a 1, not a -1. And my guess is a lot of you left the parentheses off and ended up with this being a -9 and gotten a -1. So the parentheses are very, very important. Whenever you remove a variable, you put parentheses in its place before you replace that number. All right, let's look at some of the rules for exponents, some shortcuts and some generalizations. The first one is called the product rule. And basically what it says is if you are multiplying, that's the key, multiplying 2 bases, and the bases are the same, then what you do is you keep the base and you add their exponents. So for example, 3 to the 5th times 3 to the 7th should be, according to our rule, 3 to the 5 plus 7 is 12. Notice it did not become 9. And let me show you why. 3 to the 5th means 1, 2, 3, 4, 5. times 3 to the 7th means 1, 2, 3, 4, 5, 6, and 7. If you count those up, you will see that you have 12 3s. None of them turned into a 9. So be careful with the product rule. You keep the base. You don't multiply the bases together. And the bases must be the same in order to apply the product rule. So let's try a few of those. So 4 squared times 4 to the 5th should be 4 to the 2 plus 5 is 7th. And you don't have to multiply it out. Y cubed times y to the 5th is y to the 9th. Why is it not 8? Because that's a 1. So we have 3 and 1 is 4 and 5 is 9. Here our base is -5, so you have to keep it exactly like it is with the parentheses or it's not correct. 2 to the 7 plus 8 is 15. This one should be -5 to the 16th, but I'm going to show you something that my math lab does. I am perfectly fine with this answer, just like this answer, but because this is an even number, if you wrote out all of the -5, 16 of them, they would all partner up and end up with a +5. So my math lab is going to show you this. I prefer this. That's not true on this one, because if you wrote out all of the -5s here, you would have 15 of them, an odd number, and they would not all pair up. Here, we're going to multiply like parts. So we're going to say 2 times -3 is -6, and then x squared times x5 is x to the 7th. So you're doing two things. You're multiplying the coefficients, which is just regular roll multiplication, and then applying the product rule for the bases. So what is getting multiplied here? I think it's pretty easy to see that the b is going to be to the 13th. The a is going to be to the 8th, but what do we do with that negative and that 3? Well, remember, a negative a to the 7th has an implied 1 in front of it. So it's a -1 times a 3, which is a -3. And that is what you end up with, -3, a to the 8th, b to the 13th. All right, looking at the next page, with our exponents, we have our second rule. The second rule is called the power rule because it's more powerful than the product rule. And basically what it says is, if you have one base and it's raised to an exponent, and then that whole thing is raised to another exponent, in other words, the exponent is raised to an exponent, you keep the base and you multiply the exponents. So using that, this should be 7 to the 2 times 5 is 10th. Now let me show you why. What this means is 5 copies of 7 squared. So 1, 2, 3, 4, and 5. But each of these means 7 times 7, 7 times 7, 7 times 7, 7 times 7, and 7 times 7. And I missed some dots, but whatever, you get the idea. If you put all those together, you have 10 of the 7s. So you don't want to have to do that each time. You multiply when you have an inside-outside exponent. So here we would have 5 to the 18th. Here we would have y to the 16th. So let's compare the two. The product rule versus the power rule. The product rule says if you have two bases and you're multiplying and the bases are alike, you add the exponents, x to the 5th. The power rule says I have one base, two exponents, I multiply them, x to the 6th. So the conclusion here is, how are you going to remember the difference? And you've got to come up with your own way to remember the difference between those two rules, because they're similar but very different. All right, let's look at some examples of the power rule. These are sort of intuitive. I'm not worried about you having any issue with this. If there is more than one thing in parentheses and there's no add or subtract sign, it's just a bunch of run together factors to a power, then the power belongs to everything inside. So example, 3x all raised to the 5th means 3 to the 5th x to the 5th. So the 5th power goes to each one. Same thing if you're dividing. It's a to the n over c to the n because the exponent applies to the parentheses and everything it contains. So this one would be y to the 3rd over 7 to the 3rd power. All right, so let's look at these. Here we would have s to the 4th, t to the 4th. Pretty easy. Here we would have 2 to the 3rd, a to the 3rd. And since this is a small number, you would want to go ahead and multiply that out and get 8a to the 3rd. This one you need to be careful with. It's probably best to write it like I'm going to show you. It's negative 5 gets squared, x squared gets squared, y cubed gets squared, and z gets squared. Whoops, let's scoot that over. Now, let's go ahead and simplify. Negative 5 squared is a positive 25. X squared squared is an x to the 4th. Y cubed squared is a y to the 6th. We're multiplying. Z squared. Don't try to do it in one step because what will happen is you'll forget about that negative 5. Same thing here. What's being raised to the 4th? Everything. So 2 to the 4th, x to the 4th to the 4th, over 3 to the 4th, y to the 5th to the 4th. Now we're going to go ahead and multiply the 2 and the 3 out. 2 to the 4th is 2 times 2 times 2 times 2, so 16. X to the multiply, 16. 3 to the 4th is 3 times 3 times 3 times 3, or 81. Y to the 20th. All right, if you will go back and look at that first page of your notes for just a second, you will see with the product rule, when we multiplied like bases, we added their exponents. So it only makes sense with the quotient rule, if we are dividing like bases, we subtract the exponents. I'm going to show you why in a minute. So this should be x to the 6th over x squared is x to the 6 minus 2, or x to the 4th. But let's look at y. X to the 6 would be 1, 2, 3, 4, 5, 6 over x squared would be xx like this. And if I now cross cancel ones, x over x makes a 1, x over x makes a 1, and look what I have left. 1, 2, 3, 4, and they are in the numerator. So the quotient rule, I think, is one that is easier to visualize. If you can visualize these all expanded and visualize these expanded, and then you're just crossing them off, it's much easier to remember. You shouldn't have to really write them out like that. So let's do a few of those. Here we have x to the 5th over x squared would be x to the 5 minus 2 is 3. 4 to the 7th over 4 cubed is 4 to the 7 minus 3 is 4. Notice I didn't make that a 1. I didn't cross cancel those because you have to visualize 7 of the 4s. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, and then you can see what's left. Here our base is negative 3. 5 minus 2 is 3. I would say go ahead and multiply this one out because the number is small. So it's negative 3 times negative 3 times negative 3, which is negative 27. This one you have to be careful of. I'm going to use some color here so that you can see the difference. So in green, what I have is a 1 over a 2. That's not going to cross cancel. In pink or purpley, what I have is an x5 over an x3. Look where you have more. You have more in the numerator. So basically, these 3, if they were expanded, cross cancel 3 of those, leaving 2. Now here's the tricky part. The y's in blue, look where I have more. I have more in the denominator. So these 2 would cross cancel 2 of those, leaving 2 in the denominator. So wherever you have more is where you have to leave the leftovers, and that's the easiest way to think about it. Well, what is this? This would be x to the 3 minus 3, which is x to the 0. But what is x to the 0 equal to? Well, let's go back to what we originally had. Anything over itself we know is equal to 1, so x to the 0 has to be equal to 1, and it is. And that brings us to our last property, which is the zero exponent rule, and it says that anything to the 0 power is equal to 1 as long as the n is not a 0. So here, it's a 1. Here, it's a 1, even though there's a lot of things in parentheses because this applies to everything inside. Here, it's a 1. Here, it is not a 1 because this means minus 4 to the 0 or minus 1. Be careful of this one versus this one. This one means 5 times x to the 0, or 5 times 1, which is 5. You have to be careful of those. All right, a way to remember all of these rules, because it doesn't matter to me if you know the name of them, but if your bases are the same, this says when you multiply, add the exponents. When you divide like bases, you subtract the exponents. When you have power, meaning inside, outside parentheses, you multiply the exponents.